Hello, hello, hello. Hello.
Sir.
Coming now. Hello. Hello. Audible. Okay, good. Hello, my dear students. So, can everybody see me and hear me now?
No.
Am I audible now? Okay, good, good. Nice, nice, nice. Excellent. So, okay. So, first of all, a very, very happy Makar Sankranti to all of you, to all the family members of Gosalites. May this auspicious festival keep you always happy, healthy, and peaceful. And may you all be very, very successful in your life. My best wishes to each one of you and to all your family members as well. Okay. So, happy Makar Sankranti, happy Pongal, and belated happy Bhogi to everybody. Okay. So, how's everyone doing? Hello, everybody. Good morning. Good morning. Good morning. Okay. So, today's topic is now coming, sir. You can. Today's topic is chemical equilibrium. Ionic equilibrium, boys and girls. So, ionic equilibrium is a pretty lengthy chapter. We'll try to cover the important portions as much as possible. So, are we good to go? Happy, happy Makar Sankranti, my dear kids, to you and to your family members also. All right. So, without wasting any more time, let us quickly begin with the class. Everybody, good morning once again, all of you. So, we have to primarily focus on pH calculation today. Okay, pH calculation. Okay, we'll try to cover the important portions as much as possible. I will try to teach. I'll be a bit quick. So and we will do problems also. So just focus on understanding. All right. So just give me 1 minute. Okay. Yes, boys and girls. So first of all, we will talk about pH calculation for a solution of strong acid. pH calculation for solution of strong acid. So what are strong acids? Strong acids are those which undergo 100% ionization in water, 100% dissociation. All right. And please remember the 6 names which I am going to tell you. Those 6 names are HCl, HBr, HI, HNO3, and HClO4 and H2SO4. Okay. So these are the 6 strong acids. Please remember these names. It's important. We will use this later on in salt hydrolysis as well. So the important part about these acids is that they undergo 100% ionization. All right, beta. So for example, suppose if somebody gives you that 10 to the power minus 2 molar HCl is there, you have to find the pH of it. So HCl is a strong acid and it's a monoprotic acid. It will undergo 100% dissociation. So beta, the concentration of H plus would be equals to 10 to the power minus 2 molar. Why have I been able to write this from this? Because it is a strong acid and it's a monoprotic acid. So now I hope everybody knows. I will not go too much into basics because you have already studied this topic twice. So I will have some expectations from you that you know at least little bit about it. So pH will be minus log concentration of H plus. Okay, minus log concentration of H plus. I am sure everybody can understand. This will come out to be 2. Okay, so this will be your answer. Suppose if I give you 10 to the power minus 2 molar H2SO4. 10 to the power minus 2 molar H2SO4 I give you, beta. Okay, boys and girls. So anyone, maybe in the Zoom or in the YouTube, anyone would want to give the answer for this? 10 to the power minus 2 molar H2SO4. Anybody who would want to give the answer for this pH? Everybody. 10 to the power minus 2 molar H2SO4. Anyone who would want to give the answer either in Zoom chat? Let me open the Zoom chat as well. Just give me 1 second. One second. Yes, boys and girls. pH equal to 4 is completely wrong. Okay. It will not be 4, beta. 10 to the power minus 2 molar H2SO4 would be more acidic than HCl. H2SO4 is diprotic acid. So if this answer was 2, more acidic means less pH. Do you know that? More acidic means less pH. So if this is a diprotic acid, then for the same concentration, it would be more acidic. And if it would be more acidic, then pH should be what? Less. More acidic means less pH. So here H plus concentration, boys and girls, would be double. 2 into 10 to the power minus 2 molar, because it's a diprotic acid. Because it's a diprotic acid, H plus concentration would be double. And now I would take the minus log. Acha, always remember, if H plus is equals to A into 10 to the power minus X. Just remember this form. A into 10 to the power minus X. Then pH is equals to X minus log A. Please remember this form. We will use this a lot of times in the problems. If H plus is A into 10 to the power minus X, pH is X minus log A. Yes. So over here, can you see A into 10 to the power minus X, beta? So pH will be equals to 2 minus log 2. And log 2 is how much, boys and girls? Please remember 0.3, 0.3. So 2 minus 0.3, 1.7 is the correct answer over here. Yes, very good, everybody. Well done, well done, well done. Okay, so now after this story will go on till 10 to the power minus 6 molar HCl. Till 10 to the power minus 6 molar HCl. Okay, 10 to the power minus 6 molar HCl, pH would be how much, everybody? 6. pH would be 6. Okay. Now, bringing you to the next part, NCERT solved example. NCERT solved example, important question. Okay. So if I talk about 10 to the power minus 7 molar, the M which I make sometimes looks like small m, but always treat it as capital M. Capital M means molarity. Here everywhere we are talking about molarity. Okay. Please excuse my handwriting for that. Okay. So 10 to the power minus 7 molar HCl. Everybody. So 10 to the power minus 7 molar HCl, what will be the pH? Why, everyone tell me fast. 10 to the power minus 7 molar HCl. Who will tell me the value of pH? It will not be 7 first of all. If you are saying that for 10 to the power minus 7 molar HCl pH is 7 beta, then moe just happened with you. Okay. How can it be neutral, bhai? This is an acidic solution. If you are saying that 10 to the power minus 7 molar HCl is 7, then you will not hesitate in saying that 10 to the power minus 8 molar HCl is pH equal to 8. You have put acid HCl and pH you are saying 8 means basic solution. So this answer is also not wrong. It's terribly wrong. And this answer is also terribly wrong. Okay. Yes. So for 10 to the power minus 7 molar HCl, 10 to the power minus 8 molar HCl, boys and girls, okay? For 10 to the power minus 7 molar HCl and 10 to the power minus 8 molar HCl, we have to consider the H plus coming from water also. Now the exact solution of this is quite lengthy. It involves solving a quadratic and all, which has been solved in one of the NCERT solved examples. You can have a look at it, okay? But if the question comes in the exam, please remember, just mug up the answer. Just mug up the answer for this. Remember this. You have to consider the H plus coming from water here as well. Remember that, boys and girls. So pH over here is 6.8 and this pH is 6.98. Okay, 6.8 and 6.98. Please do remember the answers. Sir, how do we get these answers? By solving a quadratic equation, which you might have. This is a revision class, so of course we will cover the most important points. So please remember this. One more question towards which I would want to draw your attention is, okay, suppose somebody asks you that pH of 10 to the power minus 6 molar HCl, pH of 10 to the power minus 6 molar HCl, and options given are exactly equal to 6, slightly less than 6, slightly less than 6, slightly more than 6. This is option 1, this is option 2, this is option 3, and option 4, I don't know and I don't care. I don't know and I don't care. So what will be your answer for this question? pH of 10 to the power minus 6 molar HCl. Suppose if somebody gives you such a question. So exactly equal to 6, slightly less than 6, slightly more than 6, or I don't know. See, many of you might think as option 1. But beta, option 1 pH of 10 to the power, if you ask me that sir what is the pH of 10 to the power minus 6 molar HCl, I will give the answer as 6. But this is not 100% correct. This is an approximate answer. In this particular see, you are giving the pH as 6 means you are trying to say that H plus is 10 to the power minus 6 molar. But this much H plus coming from strong acid only, na? What about the H plus coming from water? Sir, H plus coming from water, negligible? Yes, negligible, but it will have some value, na? It will not be 0. It will not be 0. It will have some value. So total H plus will be little bit more than 10 to the power minus 6. See, you have to understand the psyche of the paper setter also. With what intention he is giving you the question. Okay, you have to understand that, boys and girls. So in 10 to the power minus 6 molar HCl, the H plus will be equals to 6 plus some chinna amount coming from water, which will be very small, but still some H plus will be coming. It will not be 0. Okay. So if H plus will be little bit more than 10 to the power minus 6, you know that as H plus will increase, the pH will decrease. So if I go by the psyche of the paper setter, the most appropriate answer for this question is slightly less than 6. Slightly less than 6 will be the correct answer, because there will be some H plus coming from the water also, which we are ignoring. See, I am saying when pH is 6, this is approximate pH. Bhai, this is not exact pH. This is approximate pH. Please remember that. So I hope everybody understood what I am trying to say over here. Okay. So correct answer for this would be slightly less than 6 if the question is coming in this format. 2 is the correct answer over here, not 1. Okay. All right. Moving forward, everyone. Then after this, we can talk about pH calculation for a strong base. What are strong bases, everyone? Strong bases are, remember the names? Hydroxides of 1 and group 2. Alkali metals and alkaline earth metals. Hydroxides of group 1 and group 2. Except LiOH, BeOH whole twice, and MgOH whole twice. CaOH whole twice is also on the borderline, but we can regard it. CaOH whole twice is on the borderline, but still we can regard it as a strong base, okay, in most of the problems. So hydroxides of group 1 and group 2, except LiOH, BeOH whole twice and MgOH whole twice, remaining everybody is a strong base, which means they will undergo 100% what? 100% dissociation. Okay. NaOH, KOH, RbOH, CSOH, BaOH whole twice. These are all your strong bases. So how do you calculate the pH over here, everybody? Suppose if I ask you that 10 to the power minus 2 molar barium hydroxide solution is there. 10 to the power minus 2 molar barium hydroxide is there, everybody. So in 10 to the power minus 2 molar barium hydroxide, OH minus would be how much? Double. This is a diacidic base and it's a strong base, everybody. Okay. So this will be 2 into 10 to the power minus 2 molar. Going by the previous calculation, POH would be 1.7. POH would be 1.7. And how much would be pH, everybody? pH, you know how to calculate in this case? pH, I hope everybody knows. pH plus POH is equals to pKW for an aqueous solution. And at 25 degrees centigrade, at 25 degrees centigrade, pKw is 14. So your answer over here will be 12.3. This is how you will calculate for the strong base. First you will calculate the pOH and then you will subtract from 14 to get the pH. Normally we operate at 25 degrees centigrade, so this value is equals to 14. Is it okay, boys and girls? Everyone? This is 14 at 25 degrees centigrade. Chalo, quickly solve a question now. Quickly solve a question. Okay? Question is 50 degrees centigrade, Kw of water, which is ionic product of water, is 10 to the power minus 13.6. Kw is 10 to the power minus 13.6. Find pH of 10 to the power minus 2 molar NaOH solution at 50 degrees centigrade. Who gives me the answer for this? At 50 degrees centigrade, Kw is 10 to the power minus 13.6. Find the pH of 10 to the power minus 2 molar NaOH solution. Answer bhai, answer. First answer has come from Likhita. Okay. What about the Zoom chat? Anyone? See, 10 minus 2 molar NaOH solution. NaOH is a strong base. So beta, concentration of OH minus is 10 to the power minus 2 molar. And pOH is equals to 2. pOH is equals to 2, right? And pH is equals to pKw minus pOH. pH is equals to pKw minus pOH. Till now, you were putting pKw as 14, but that was at 25 degrees centigrade. Now you don't have 25, you have 50. And pKw at this temperature is how much, everyone? Kw is 13.6, so Kw is 10 to the power minus 13.6. So pKw is 13.6 minus 2. That is equals to 11.6. Very good. Well done. That is your answer. Is it fine, boys and girls? Very good. Very good. Very good. Well done. Let's move on. Next problem, everybody. Next question is that suppose if I give you 10 to the power minus 7 molar NaOH, and suppose if I give you 10 to the power minus 8 molar NaOH. Acha, Zoom chat is, no, I can see them. Acha, messages are, I can get your messages. Chat is disabled, but messages I can see. Okay. Yeah. Okay, chalo, theek hai, no worries. You can calculate the answer. 10 to the power minus 7 molar, 10 to the power minus 8 molar, pH. Cheppu by pH, Cheppu fast. What is the answer for pH? (10 to the power minus 7 molar NaOH. See, please use the answers for 10 to the power minus 7 molar HCl and 10 to the power minus 8 molar HCl. Over there, whatever happened for pH, the same thing will happen for pOH this time. And for 10 to the power minus 7 molar NaOH, you remember pH over there was 6.8. Now pOH be 6.8 and 6. 98. Remember, solution of NaOH at 25 degrees centigrade, solution of any base at 25 degrees centigrade has to be more than 7, and acidic solution has to be less than 7. Okay, so pOH will be this value, and normally I talk about 25 only. So boys and girls, pH would be 14 minus 6.8, that is 7.2. This is 7.02. So this is your answer for pH. Please remember it carefully. Sir, how do these answers come? They come by solving the quadratic, which we will not waste our time in solving. Okay. All right. Next, after this, we can learn little bit how to take anti-log also. Okay. How to take log, that also we can learn. So first of all, I hope all of you remember the values from log 1 to 10. This is extremely important, log 1 to 10 values, although most of the times they are given in the problem, but still you should know this, yaar, hai na? So log 1, very quickly, I will not write it down, I will recap. Log 1 sunna, log 2 0.3, log 3 around 0.48, log 4 0.6, log 5 0.7, log 6 around 0.78, log 7 0.84, 85, 0.84 roughly you can think, log 8 0.9, log 9 0.96, and log 10 1. Please remember these logs. Okay, so now boys and girls, we will do a question. I'm writing the question in short. Okay, so you have 1 liter solution of strong acid, 1 liter solution of strong acid whose pH is 2.1. 1 liter solution of strong acid whose pH is 2.1. Okay, question is asking you that how much water should I add over here? How much water should I add over here so that I get a new solution whose pH is 4. Okay, see, if you add water, the solution will become dilute. If the solution will become dilute, molarity of H plus will decrease and pH will increase. pH will increase. Okay, so how much water should I add so that the pH becomes 4? So how to do this question? This is a indirectly this question is based upon law of dilution. But before that, you need to learn how to take the anti-log. Okay, so very quickly, see, pH is 4 over here. This is the original solution, this is the final solution. Is this Telugu class? Yes, I will teach Telugu after some time. Okay, actually I am a Telugu teacher only, just for some fun. Sometimes I teach chemistry also. But after some time, we will start with Telugu. Okay. Is this class for long term? This class is for ionic equilibrium. Anyone who wants to revise ionic. Okay. So pH is equals to 4. So over here, beta, pH, this class is for anybody who has some idea of ionic equilibrium. Whether you are from junior, whether you are from senior, whether you are from first long term, second long term, whichever long term you are, if you have some idea about ionic, if you are completely blank, if you don't know anything about ionic, then this class is not for you. Okay. pH is equals to 4. So pH is equals to 4 beta. So molarity of H plus would be 10 to the power minus 4 molar. If pH is 4, then molarity of H plus would be 10 to the power minus 4 molar. My question is, when pH is 2.1, see, if it is a whole number, you can very easily take the anti-log. If it is a whole number, you can very easily take the anti-log. Okay. My question is, if it is not a whole number, if it is fractional, why H plus concentration decrease? Beta, because you have diluted, na? Water, add, dilution, mole concept, dilution formula. If you add solvent, molarity will decrease. Okay. So my question is, when it is not a whole number, when it is fractional, 2.1, 2.7. Then how you calculate the molarity of H plus? So pay attention everybody. I am teaching it to you on our next slide. How to take anti-log. How to take anti-log, written in French. Okay. How to take anti-log. So pH is 2.1. So H plus would be 10 to the power minus 2.1. Okay everybody. H plus is 10 to the power minus 2.1. So beta, whenever you get a fractional number like this, you break it into the next higher whole number. Like 2.1 you will break as what? 3. Next higher whole number is what? 3. Next higher whole number. Next higher whole number. So you will write over here minus 3. Minus 2.1 is there, so I have written minus 3. And then I will write what? 0.9. Minus 3 plus 0.9. This is how I will split this 2.1. Next higher whole number. Minus 3 plus 0.9. Now, I hope everybody knows the basic law of indices a to the power x plus y. A to the power x plus y is a to the power x into a to the power y. So this, my dear boys and girls, becomes 10 to the power minus 0.3 into 10 to the power 0.9. And moment you do this, this should remind you of something. This 0.9 should remind you of something, hai na? One very famous Shah Rukh Khan movie from my generation. I don't know whether you remember it or not. Kuch Kuch Hota Hai. Kuch Kuch Hota Hai was a very hit movie of our generation. Okay. Kuch Kuch Hota Hai means something should happen. Oh, something is happening. If I do a very crude transformation or translation in English, so kuch hota hai means something is happening. So as soon as you see this 0.9, kuch hona chahiye. Okay, something should happen. And the moment you see this 0.9, you should be reminded of log 8. Log 8 is 0.9, boys and girls. I told you log 1 to 10 you should remember. Log 1 to 10 you should remember. Okay. So if log 8 is 0.9, you know that in log base is 10. So 10 to the power 0.9 can be written as 8. 10 to the power 0.9 can be written as 8. So if you put 8 over here, what do you, ek minute, what have I done? Why did who? Acha, oh, sorry, I have written minus 0.3, nahi, minus 3, na? Sorry for this mistake. I think somebody pointed it out in the chat also. Thank you so much. This is minus 3 plus 0.9. So this will be 10 to the power minus 3 into 10 to the power 0.9. Okay, boys and girls. So now I told you 0.9 should remind you of something. So this will be what? This will be log of 8. So 10 to the power 0.9 is log 8. And this one will become how much, everyone? Final answer. 10 to the power 0.9 will be written as 8. Please make the correction over here. By mistake, I wrote it as 0.3. I'm so sorry. You can change it. 8 into 10 to the power minus 3 molar. This was a small correction, please. Okay. Extremely sorry. My apologies for that. So this is how you take the anti-log, everybody. So now means this pH equal to 2.1 can be written as 8 into 10 to the power minus 3 molar. So beta, this is the initial concentration. This is the initial volume. This is the final concentration. Final volume is, let us say, V2. Do you know the dilution formula, everybody? Dilution formula, M1 V1 is equals to M2 V2. Solve it and find V2 for me, everyone. Solve it and find V2 for me. Let's see who gives the correct answer, everyone. M1 V1, M2 V2. Apply dilution formula and tell me what is the value of V2 you are getting. 8 into 10 to the power minus 3 into 1. is equals to 10 to the power minus 4 into V2. So V2 comes out as 80 liter. But is this your answer? Will you add 80 liters of water? I am asking how much water should be added. Yes, bhaiya. So final volume is 80 liter. Initial volume enta 1 liter. Final volume enta 80 liter. So volume of water added. How much? Chepandi fast. 79 liter. 79 liter is your answer. Is this okay, everybody? Yes, all of you. 79 liter is your answer. Yes, excellent, very good. You want to do some more practice on anti-lock, or did you understand this example? Have you understood this example, everyone? Some more practice on anti-lock, or shall we move on to monoprotic acid? Chalo, do 2 questions. Do 2 more questions on anti-log. Okay, this might be little bit new for you. I'm not too sure, but I'm just guessing. So, chalo bhai, pH is, and do it fast now, do it fast. Do it fast. pH is 3.7. H plus is how much? Fast, quickly. pH is 2.3. How much is H plus? See, how fast we will do. This is 10 to the power minus 3.7. Minus 3.7 I will write as what? Minus 3.7 I will write as minus 4 plus 0.3. 0.3 reminds me of log 2. So answer is 2 into 10 to the power minus 4 molar. Quickly you have to think. 2 into 10 to the power minus 4 molar. pH is 2.3. So H plus is how much, everybody? 10 to the power minus 2.3. Minus 2.3 I will split as what? Next higher whole number. So I will write it as minus 3 plus 0.7. Minus 3 plus 0.7. Minus 3 plus 0.7 reminds me of log 5. So answer is 5 into 10 to the power minus 3 molar. 5 into 10 to the power minus 3 molar. So this is how quickly you can solve, everybody. Okay, boys and girls. Chalo, next after this we will talk about weak monoprotic acid. Weak monoprotic acid and weak monoacidic base. Only these 2 are in our syllabus. Weak monoprotic acid and weak monoacidic base. Sir, what would be a weak monoprotic acid? Weak monoprotic acid would be anything other than those 6 acids I told you. All acids other than those 6. HCN, acetic acid, HNO2, formic acid. So many acids can be there, okay? So for weak monoprotic acid, the 3 very important formulas for us are alpha is equals to under root Ka by C. Concentration of H plus is under root K into C. pH is equals to half pKa minus log C. These are the 3 very, very important formulas. All these formulas are valid when alpha value is very much less than 1. To be more specific, when alpha less than 0.05. Some people say 0.1 also, that is also okay, not a problem. Roughly same answer you will get. Because if you don't use the approximation, then the question is not a neat question. Okay, like for example, if you are solving somewhere and a question comes that you have to solve the quadratic, then I always say this in the class also, that you must once check the question paper, whether you have appeared in the NEET exam only or by mistake someone has given you JEE advanced question paper, okay? So 99% of the times, these are the 3 important formulas. around which your entire logic would be based. Okay. What is Ka? It is known as acid dissociation constant. I hope everybody knows about this weak monoprotic acid dissociation constant. All right. Then after this, weak monoacidic base. Here also, you have alpha equal to under root Kb by C. Second formula, concentration of OH minus is under root Kb into C. Third formula, POH is equals to half PKb minus log C. And if you know the POH, you can subtract from 14 and get the pH. If you know the POH, you can subtract from 14 and get the pH. Again, this formula is valid for alpha much less than 1 or alpha less than 0.05. Again, 0.1 can also be there, doesn't make too much of difference. Okay, 0.05, 0.01, both are correct. 0.1, sorry, not 0.01. Okay, so these are the basic formulas for weak monoprotic acid and weak monoacidic base when our approximation is correct. So let us have a look at some problems over here. Let's have a look at some problems. Okay. So suppose somebody tells you that, let's begin with a very basic question. 10 to the power minus 2 molar acetic acid solution is 2% ionized. 10 to the power minus 2 molar acetic acid solution, aqueous solution of course, acetic acid is a weak acid, is 2% ionized. Question says everybody find pH. Find pH. So what do I do over here? Everybody, H plus is equals to, acha, you might say ki sir here to K not given. How to do beta? K not needed. See, over here you have to solve it from the basics. You have acetic acid. Suppose this is acetic acid aqueous and it is undergoing ionization into everyone what? H plus aqueous plus CH3 CO minus aqueous. Anyone ready with the answer? So do you know how to write the progress using alpha? How to write the progress? How to write the progress using alpha? This is C, this is sunna, this is sunna. Degree of dissociation will be C. Suppose if degree of dissociation is alpha, so you have C into 1 minus alpha, C alpha, C alpha. Okay. Normally in these formulas, our first step is that we calculate alpha. Then we use this. These formulas are needed when alpha not given. When alpha not given, first you have to calculate alpha and then you have to proceed like this. Okay. But this is a much more direct question, beta. Here you have been given alpha and I have to find pH. pH means what? Molarity of H plus. So molarity of H plus how much? C alpha. C here, alpha here. Bas, that's it. C alpha directly given, na? No need for any formula over here. So it is good to know the formula, but it is not good to be a slave of the formula. You should not give up on the basic understanding of the topic. You should know the formula. I'm not saying that you shouldn't know this. But you should not forget that what is the use of it, when it is needed, when it is not needed. Okay. This is a very, very direct question. Simply C alpha you have to do. That's it. So know the formula. Don't be a slave of the formula. Don't be over dependent. Okay. So everybody, now molarity of H plus would be 10 to the power minus 2 into 2 upon 100. This is percentage, na? So 2 by 100 I have to do over here. Yes, everybody. So 2 into 10 to the power minus 4 molar. 2 into 10 to the power minus 4. pH is 4 minus log 2. 4 minus log 2 is 3.7. 3.7. This is the answer. 3.7. Is this okay, everyone? All right, chalo, do the next question quickly. Next question is that 10 to the power minus 1 molar acetic acid, Ka is 2 into 10 to the power minus 5. Find pH. Find pH. Chalo, everybody do it. Think about it for 2 minutes. So what do we do over here, everybody? H plus is equals to under root of Ka into C. Ka is 2 into 10 to the power minus 5. C is 10 to the power minus 1. So what do I get from here? I get under root 2 into 10 to the power minus 6. This becomes H plus is root 2 into 10 to the power minus 3 molar. But you know that these formulas are not always applicable. Although 99.99% in NEET it will not matter and it will always be applicable. But still, for the sake of your mind, because you know that NEET is an ever evolving exam. And especially after 2025, we should be prepared for all the situations. So statements like this will not come in NEET, this is not a part of syllabus, okay, this is too tough, this is too lengthy, are no longer acceptable from anybody, neither from the student nor from the teacher, okay. So that is why you should have idea. If something is coming in JEE Mains, you should not be completely unaware about it, okay. So this is okay, but still at the back of your mind, you know कि भाई these formulas are valid when alpha value is small. So for the peace of your mind, you should once check under root Ka by C. You should once check under root Ka by C, which will be equals to, okay, because I told you now over here that these formulas are applicable when alpha is small. So you should, for the sake of your mental peace, you should once check 2 into 10 to the power minus 5 upon C, that is 10 to the power minus 1. So beta, how much do I get from here? Root 2 into 10 to the power minus 2. Root 2 into 10 to the power minus 2, which is small. So means it is correct only, okay. Now bhai everybody, I have to take minus log of this. So minus log of this will be 3 minus log of root 2, and you know that power comes out of the log, so this will become 1 by 2 log 2. 1 by 2 log 2 will be 0.3 by 2, 0.15. 3 minus 0.15, 2.85 is your pH. 2.85 is your pH. Okay, everybody? Understood, all of you? Boys and girls? Handsome boys, beautiful girls, everybody understood? All right, good, very good. Chalo, do one more question quickly. One more question I am giving you. Quickly have a look at it. So we have 300 ml 0.2 molar weak monoprotic acid solution. Okay. K is 10 to the power minus 5. Again, the question is asking how much water should be added to double the alpha. You know about Ostwald's law of dilution. Ostwald's law of dilution. What does Ostwald's law of dilution state? Ostwald's law of dilution states for a weak electrolyte, if you decrease the concentration, means if you dilute the solution, then value of alpha increases. For a weak electrolyte, if you decrease, chemical equilibrium revision has already happened, Sumati, in the previous class. For a weak electrolyte, if you decrease the concentration, alpha value increases. Next revision will happen once you are over here. These are just some classes to keep you busy during your holidays, so that you don't, we want you to celebrate, but we don't want you to only celebrate. Okay? Celebration is the requirement of any festival. But at the same point of time, you must always little bit stay in touch with your studies. So that is the only purpose of this class. Okay? That is, you are not completely off the radar for 7 days. 2 days back only I was watching one podcast of Michael Phelps, the famous swimmer. So he said whenever he took 1 day off, it took him 2 days back to rebuild that rhythm. So if you completely stay off the radar for 7-8 days, then you lose touch. So it will take you double the time to again regain that rhythm. So that is the only purpose of these classes, that you are in touch. You remember there is something called pH, there is something called weak acid, there is something called strong acid. That is the only purpose, right? I think you have already done this twice, and in your classes once again, if you are a senior student that is in class 12, then once your IPR exams are over, once again there would be one more round of revision would be there. Okay? So I'm just trying to cover as many things as possible in one class. Okay? So 300 ml, 0.2 molar HA, Ka is 10. So I was talking about Ostwald's law of dilution. That is, weak electrolyte, if you decrease the concentration, the value of alpha will increase. So here they are saying that I have a weak monoprotic acid, which is of course a weak electrolyte. So I am adding water to it, so its molarity will decrease. The question says how much water should I add so that the value of alpha gets doubled. So try this question for 1-2 minutes, then we will discuss the solution. Try this for a couple of minutes, then we'll discuss the solution, okay? So everybody is enjoying Pongal at home? All of you celebrated Bhogi yesterday? See, what we'll do over here is that we will calculate the question is, I am diluting the solution. So alpha is increasing. How much water should I add? So alpha gets doubled. So I calculate the initial alpha. Initial alpha is under root of 10 to the power minus 5 upon under root Ka by C. C is how much? 2 into 10 to the power minus 1. So this will become 10 to the power minus 4 under root 10 to the power minus 2 upon root 2. 10 to the power minus 4 under root 10 to the power minus 2 upon root 2. Now, final, I want this alpha to become 2 times. So if I multiply this by 2, I get root 2 into 10 to the power minus 2. I have doubled it. Yes, 900 ml looks the correct answer. Given by, who is that? Raji 1659. Yes, that's correct. So root 2 into 10 to the, very good. Root 2 into 10 to the power minus 2. Everyone? Okay. This is after becoming double. And you know K is an equilibrium constant. So K will remain the same. K is an equilibrium constant, so Ka will remain the same. That's not going to change. And now if you square it on both the sides, you get 2 into 10 to the power minus 4. Squaring both the sides is 10 to the power minus 5 by C. So C is equals to 10 to the power minus 1 by 2. That is 0.05 molar. 10 to the power minus 1 by 2, 0.05. So now you have to apply M1 V1 is equals to M2 V2. So 0.2 M1 into V1 300 is equals to M2. M2 तो we know na, M2 is how much? 0.05 into V2. So this cancels, I guess, 4 times, and V2 is equals to 1200 ml. V2 is 1200 ml. Now initial volume was 300, new volume is 1200. So everybody, volume of water is how much? Volume of water added is 900 ml. 900 ml. Is this okay, everybody? All of you? Got it? 900 ml of water added. Okay, next after this, we will briefly discuss one more topic we can take. Salt hydrolysis. Salt hydrolysis we'll discuss, okay? So very quickly, everybody, let us discuss briefly salt hydrolysis. Everyone. So see, what is salt hydrolysis? Salt hydrolysis is just like weak monoprotic acid and weak monoacidic base. Okay. Salt hydrolysis basically means that once you dissolve the salt in water, then beta, what will happen? First of all, the salt will undergo dissociation into cation and anion. Okay. First of all, the salt will undergo dissociation into cation and anion. And then the cation and anion may further react with water. So once they will react, that reaction is known as hydrolysis. Okay. Now always remember that cation in the salt comes from the base. Like if you consider NaCl as a salt. So NaCl has Na plus, which is coming from, try to think how NaCl would be formed. So NaCl would be formed by the reaction between NaOH and HCl. So NaOH plus HCl reaction will give you NaCl plus water. So the Na plus in the salt NaCl is coming from where? It's coming from NaOH. So basically the base supplies the cation. And the base can either be a strong base or it can be a weak base. Strong base, but I told you, NaOH, KOH, except LiOH, BeOH whole twice, MgOH whole twice. Other than them, rest everything is a weak base. Okay. So the cation comes from the base. The base can either be a strong base or a weak base. If it is a strong base, cation, if it is a strong base cation, if the cation is of the strong base, then hydrolysis ledu. No hydrolysis. It will not react with water. Cations like Na plus, K plus, Rb plus, Cs plus, Ba2 plus, etc., etc. They will not react with water. No hydrolysis. Okay. But if the cation is coming from a weak base like NH4 plus, Li plus, okay, Li plus, then you have lots of weak bases derived from ammonia. Like there is a very popular base aniline. So aniline ka cation will be what? Ammonia gives you ammonium. Aniline will give you anilinium. So this is anilinium. Then after this you can have so many other things. Pyridinium. Pyridinium can be there. So pyridine is also a weak base. So this is the, like ammonia gives you ammonium, aniline will give you anilinium, pyridine will give you pyridinium. So if this type of cation is there, it will behave like, if this type of cation is there, then hydrolysis, it will undi, hai na? Hydrolysis will happen. So cation of strong base, hydrolysis le do. Cation of weak base, these examples, they will undergo hydrolysis. Sir, what do you mean by hydrolysis? They will react with water. How will they react with water? Let's discuss that. So so we are discussing cationic hydrolysis, okay? So any cation, suppose B plus, any cation B plus, whether you know its formula or not, okay? When it will undergo a reaction with water, this reaction with water will be called as hydrolysis of cation, or it will be called as cationic hydrolysis. And which cations will undergo hydrolysis by everybody? These cations which are coming from weak base, they will undergo hydrolysis, okay? So B plus water, any cation undergoing hydrolysis. See, water is made up of H plus and OH minus. So this positive charge will attract what? It will attract OH minus from water. Cation plus will take up OH minus from water and it will form BOH aqueous. Now, once it steals away OH minus from water, what is left, boys and girls? You are left with H plus aqueous. So, bhai, moral of the story, it will behave just like a weak monoprotic acid. Just like a weak monoprotic acid. Simply like a weak monoprotic acid. Okay? And how will you solve it? Let us say concentration is C initially. This is 0. This is 0. By this is the solvent. This is present in large excess. We are not bothered about it. Then suppose degree of hydrolysis. Acha, over there we use the symbol alpha. Over here we use the symbol H. There we use alpha. Here we use H. Meaning is same. Name is the same but different. Meaning is same. Name is different. This is called degree of hydrolysis. Degree of hydrolysis. Okay. And you will have C1 minus H. Here you will have CH. Here you will have CH. And the equilibrium constant of this step will be called as KH, hydrolysis constant. Acha, one very common doubt. Question asking for degree of hydrolysis, then you have to calculate H. Question asking for percentage hydrolysis, then you have to calculate H into 100. Percentage hydrolysis is H into 100. Question asking for hydrolysis constant, then you have to calculate this. Please, if base is from group 2, it will be diprotic. Yes, Aradhya, but only one step hydrolysis we will consider. Because here also, if you remember, I only spoke about weak monoprotic acid, na? I did not discuss about polyprotic acid. So just in case you know about polyprotic acid, your question is very legitimate. In case you know about polyprotic acid, so polyprotic acid has K1, K2, K3, like H3PO4 is there. So we only consider the first step. In case you know that theory, pH calculation for a weak polyprotic acid. So weak polyprotic acid beta has K1, K2, K3. Okay. Similarly, if the cation will be from, let's say, group 2, like Ba2 plus, etc. So that will be like a that would be polyprotic anion, polyprotic cation or polyprotic anion. Like 2 steps hydrolysis will be there. Yes, Malini, please type your doubt. I will try to help you out. So when the question is asking for degree of hydrolysis, you will tell H. You are saying like one thing, sir. I am saying so many things, not one thing. Okay. So degree of hydrolysis, if question is asking, you will tell this. If percentage hydrolysis question is asking, you will tell this. And hydrolysis constant, you will say this. Everyone can have their own different methods. Okay, you are talking about that particular thing. Okay, so all right. So I hope this is clear, everybody. Degree of hydrolysis, hydrolysis constant, and percentage hydrolysis. These are the three different things. Okay. Now we will be having. So this will behave just like a weak monoprotic acid. So for a weak monoprotic acid, beta, how do we calculate the pH and all? Everybody pay attention. Okay. Malini, focus on the class. Not that was just an example. Let's not overstretch it. Okay. So how do you calculate? So you remember the three formulas. H is equals to under root of K by C. Okay. That K will become what? KH and K will be same over here. Okay. KH is equals to K, right? So H is under root K by C. pH is equals to by I told you, it is just like a weak monoprotic acid. And beta, if it is just like a weak monoprotic acid, pH will be half pKa minus log C. So pH will be equal to half pKa minus log C. But here comes the important part. Okay. Most of the time, suppose for a moment, everybody, suppose this cation is NH4 plus. This cation is NH4 plus. Okay. Now NH4 plus is behaving like a weak monoprotic acid. But most of the times in the questions, you will not be given the Ka of NH4 plus. You will be given the Kb of ammonia. Okay. Similarly, if the question is of pyridinium, you will not be given the Ka for this. You will be given the Kb of pyridine. Okay. So always remember, for a CaCb pair, ammonia, ammonium, pyridine, pyridinium, aniline, anilinium. Okay, this one was anilinium, not pyridinium. This is pyridinium. This is anilinium. So for a CaCb pair, beta, everybody remember that Ka, this can be derived also. I am not going into the derivation. Okay. So for a CaCb pair, Ka into Kb is equals to Kw. For a CaCb pair, K into Kb is equals to Kw. For a CaCb pair, I am not saying that you take any random acid and you take any random base. You take any random acid and any random base, then this is not applicable. For CaCb pair, conjugate acid base pair, K, Kb is Kw, and pKa plus pKb is equals to pKw. Please remember this. So therefore, boys and girls, in this formula over here, while you are applying this formula, you will not be given the pKa of the ammonium. You will be given the pKb of ammonia. So therefore, your formula becomes half, which you can simply derive like this. You don't have to think on the spot. You don't have to memorize it. So in place of pKa, what will I put? In place of pKa, what will I put, everybody? pKw minus pKb. Okay, I hope you understood this. So pKw minus pKb minus log C. This is your formula in case of cationic hydrolysis, where only cationic hydrolysis occurs. Only cationic hydrolysis. Okay, no anionic means NH4Cl, NH4Br, LiCl, okay, LiBr, pyridine, anilinium bromide, and even somebody asked, I think Aradhya, even if you have from group 2 beta, you will only consider the first step. anilinium chloride. All these salt solutions will be what? They will be acidic in nature. They will be acidic in nature because of the hydrolysis of the cation. And it will be just like a weak monoprotic acid, half pKa minus log C, but most of the times pK will not be given, pKw minus pKb will be there. Is this okay, everybody? All these salt solutions will be acidic due to hydrolysis of the cation. Yes, sir. Yes, absolutely. Everybody. All right. Now, next we will quickly discuss anionic hydrolysis. Anionic hydrolysis. Okay. Anionic hydrolysis. So, anion in the salt comes from the acid, like NaCl में Cl minus, okay, comes from HCl. All right. Similarly, it comes from HBr like that. So anion comes from the acid. And once again, the acid could be a strong acid or it could be a weak acid. Anion of strong acid would be, remember the name, Cl minus, Br minus, I minus, etc. Dot. Anion of weak acid, you remember, anion of weak acid would be Cn minus, NO2 minus, okay. Then after that you can have maybe acetate, etc. So these anions, hydrolysis le do. These anions will undergo hydrolysis. And once they will undergo hydrolysis, they will behave like a weak monoacidic base. Just as Cn minus, if you dissolve in water, okay, it will give you HCN plus OH minus. HCN plus OH minus, right? This is how it will take up H plus from water. And once again, same old story will continue. C00, C1 minus H, CH. And this will behave like a weak monoacidic base. So for weak monoacidic base, you remember the formula POH is equals to half pKw. Okay, sorry, POH is equals to half pKb minus log C. But pKb will not be given. Most of the times pKa of the conjugate acid would be given. So you would do what? pKw minus pKa minus log C. Half pKb minus log C, but pKb will not be given. pKa would be given for the conjugate acid. Most of the times. Not always, most of the times. Okay. So that is how you will calculate the pOH. And once you get the pOH, pH will be 14 minus pOH. You can get the pH also. So we have tried to cover the most important cases. Okay. So which will be salts of this type where only anionic hydrolysis is happening? NaCN, KCN, sodium acetate, okay, KNO2, all these salt solutions would be basic in nature. They would be basic in nature. Is it okay, everybody? Beta Neptune, we had just one class, so from my side I have tried to cover as much as possible. PYQs you can solve on your own. It's not possible to, ionic is a pretty lengthy chapter. In one class I have tried to cover the important things as much as possible. PYQs will be there in the module. Yes, of course they are there. Of course they are there. Okay. JEE mains and NEET, some JEE mains PYQs are also there and NEET PYQs are also there. Okay, everybody. So I'll take your leave on that note and revise this very important chapter. Revise this very important chapter, okay, boys and girls, and wish you all a very happy Sankranti once again. To you, to all your family members, enjoy this day, celebrate, and may all of you be very, very successful, happy in life. This is my honest wish from the bottom of my heart. I hope you may realize all your dreams, be happy, be successful, be content, be peaceful, and be healthy. Bye bye, guys. Have a nice day. Take care. God bless you all. Okay? Bye. Somebody wants to say something? Ruchi ma'am is okay. She's good. Good. Okay, bye. Bye, boys and girls. Take care. In chemical equilibrium class was not telecasted on YouTube, I think. QR code. Okay. I think it's taking some time, so I have to rush for the next class after this. So once it's done, I think I will inform the person over here. They will share it. Okay. So bye everyone. Have a nice day. God bless you all. Take care.